In this video, we're going to be looking at the mean and where that usually appears and what we have to do. So most students, even from science, you know about the mean. You kind of add things up and then divide it by how many there are. That is how we essentially do the mean. So if we just quickly do 1, 2, 7, and 10, then we would add those up, 1 plus 2 plus 7 plus 10, and we divide by how many there are, 1, 2, 3, 4 in this case. Okay, 10 plus 7 plus 2 plus 1 is 20, divided by 4 is 5. Okay, so this is the basics around the mean. And then what happens in exams is that we actually have to do the mean from a table. Okay, so this table will have a frequency here, and this first column can literally be anything. It could be shoe size, weights, lengths, anything. So I'm just going to call it X for now because it always goes on the X axis, but also because it can be literally anything. Let's say shoe sizes or something. So shoe size of 3, 4, 5, and 6, and 2, 3, 4, and 7. Okay. To do the mean, it's a good idea to understand what this frequency table is actually showing. If I write this out in full, we've got, I'll do it over here, 2 people with a shoe size of 3. We've got 3 people with a shoe size of a 4. 4 people with a 5. And 7 people with a 6. 1, 2, 3, 4, 5, 6, 7. So really all we have to do is add all of those numbers together and divide by how many there actually are. Okay. However, in the exam, there could be sort of 30, 40, 50 people in this frequency table. So we do not want to write this out fully. We are expected to add our own column, which might not have a space for it. So we might have to add that on, which is frequency times whatever's in this X column. Okay, so if you look at the 3's, the total of the 3's is 6. 3 times 2. 1, 2, 3, 4. Sorry, I did that wrong. 3 people were on a 4. There we go. So that is 12. 3 times 4. 4 people on a 5. That's 20. And 7 people have a 6. That's 42. So that means we don't have to write all of these out. And even I made a mistake there. It's very easy to do. So we just multiply these together. And then the total of the top of the numerator, where we add everything together, is just the sum of this column. 42, 62, 74, 80. Okay, 40, 50, 60, 72, yeah. Okay, so the total on the numerator is 80. So that's going to be an 80. And then we have to divide by how many people there were, which is actually this column added together. 7 plus 3 is 10, 14, 16, like that. Okay, so the mean from our table is going to be 80 over 16. Is that 5? Just so happened to be a nice round number there. So our mean shoe size is a 5, and that's how we do it from a table. What happens if your table, instead of having individual numbers like this, actually has a class or an interval, something like 0, x, 10, 10, x, and 20, that kind of thing? Your frequency will still be here, and we still need to do frequency times x, but we need another column, which is the midpoint of the class. So 0 to 10, we approximate this as 5. 10 to 20, the middle of that is 15. So as soon as we go into the realms of a grouped frequency table like this, then our mean then becomes an estimate, because we have no idea what's going on in this class. Okay, does everyone have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like evenly spread, or is it 10, 10, 10, or 9, 9, 9, or 6, 6, 6, or whatever it is? It can't be 10 in that first one, but 5.5. We have no idea what's inside that group. So when we go down the middle like this, we're making an approximation. Okay, we're saying that the data in that class, that interval, is evenly distributed. Okay, and at the very highest level, they sometimes ask why this is an estimate, and it's because we've assumed by doing this that the data is evenly spread.